Now to look at integration in a lot more detail. We'll start off with strategies. The first strategy is to look for something obvious, so an obvious solution. So in other words, look in the integral and can you find some function in the integrand where the derivative of that also occurs. So you could set up derivative times function, that sort of thing. So like this, so you look at it and you can see, yeah look, I've got this function x squared and I know the derivative of x squared is 2x, I've got that as well. So you're looking for those sorts of things. That means I could rewrite this, manipulate it around so it is in the form of derivative times function. In this case, it's du on root u, that's 2 root u, we get minus square root of 1 minus x squared. So we see the obvious one can save us some time. Sometimes we have to do some manipulation to get it into that standard form. Remember, that's why we have the standard integrals. Saves us time. E to the power of x plus e to the power of x. This is possible to be manipulated. If I use my index laws, what this is really saying is e to the x times e to the x. I actually have now got derivative times e to the function, because the derivative of e to the x is e to the x. Now I have got it in that form. Therefore, this is e to the x. This one here, haven't got the derivative, but x on 2, this is inverse tan. I've got derivative on the function squared plus a constant. I can manipulate this one to get it into that inverse tan form. There it is. Remember, in the denominator, I want to get it to a plus the function squared. Now, if that derivative is going to be e to the x on 2, then I need to get this as e to the x, because that would be e to the x on 2 squared. That's why I pulled the 3 out. Balancing the numbers up, I have it in a standard form. A bit of a tricky manipulation. But now I've got that, I can say, well, that's 4/3, 1 on root 2, inverse tan of e to the x on 2 over root 2, tidy it up. Simplify the integrand, if possible. That would be nice. The algebraic manipulation, trig identities, they're two key ideas for playing around with these questions. Something like that. I have derivative and I have function, but it's not the way I like to see it. Because I would like derivative on function here, I'd turn it into a log, not function on derivative. What do I do? Well, I'll just change everything to sines and causes. So that's the thing. With trig, if I can't see something straight away, this is always an idea. Change it to sines and causes and maybe something drops out. In this case, cos cancels with the cos squared. I get sine theta cos theta. That's a half of sine 2 theta. Or I suppose I could have looked at it and said, now I've got derivative times function either way. And I get minus a quarter cos 2 theta here. Now, x cubed times the square root of 4 minus x squared. The derivative of x cubed involves x squared, but my x squared is under the square root sign. So I need to do a different type of manipulation. I'm going to factorize this. And you look at it and go, what? Factorize? How does it factorize? It does with a bit of manipulation. I'm going to factorize using the expression inside the grouping symbol. So in this case, under the square root sign. That's the key. 4 minus x squared. I want a multiple of that function or its derivative, and the derivative would be minus 2x. Playing around with that, I can do that. I can turn x cubed into minus x times 4 minus x squared plus 4x. And then I got it. Because now I can break it into two things, and those two things can now both be integrated. Because I have it derivative times function. Okay, some multiple of the derivative, but for both of them. I can add 1 to the power over the power and get my answer. That's a tricky little algebraic manipulation, but that's what you're looking for, the function and its derivative. So some sort of factorization involving those things. What the integrand actually looks like, the form of it, can give us a clue as to how to approach it. So if we see rational functions, just polynomials, things like that, then polynomial divisions and the idea of partial fractions, which we'll look at in this topic. Trig functions, whatever the power of the trig is, that will give us a clue as to which technique to use. If you've got a mixture of function types, so maybe an exponential and a trig function, integration by parts, and that'll be a technique that we'll look at. Pretty much every integral can be broken down to one of two ideas. Some sort of substitution or will I do it by parts? Pretty much every one of the ideas is that, one of those two things. So we'll just start off with looking at some integrals, 4a and 4b, trying some of these ideas.